Okay, so up until now, we've only been dealing with trigonometry in terms of right-angled triangles. But trigonometry can be used for all sorts of triangles. It can be used for other things other than triangles as well, although kind of strangely it is always related to a triangle. But higher level maths, we start thinking of these as periodic or circular functions sometimes as well. So, but the step that we're going to make in standard maths is to start thinking about non-right-angled triangles. Now, the thing about a right-angled triangle, which I've got here, is we know that given that this is going to have to be 90 degrees, that angle there, and that the total amount of degrees in a triangle is 180, that means that both of these two angles here in this triangle must be less than 90 degrees. They have to be acute angles. There's no other way for it to work out. The largest angle in any right angle triangle is going to be the right angle. So we never really have to deal with the sine, cos and tan ratios over 90 degrees when we're dealing with right angle triangles. But when we have a triangle like the one on the right here, if I was interested in this angle here, using methods that we're going to cover over the next couple of lessons, then that's an obtuse angle, and that creates a couple of little problems with trigonometry, in particular with the sine and the tan ratio. So there's some little understandings we've got to have in relation to obtuse angles and trigonometry. So what happens often is the calculator will give us an answer which will assume we're looking for an acute angle, and then we need to understand ourselves, is that angle supposed to be acute or is it supposed to be obtuse? So what I want you to do, and I'll get you started with a couple of these here and then I'll complete the table, but I will pause on Edpuzzle so you guys can complete the table yourselves. What I want you to do is sit there with your calculator and put in a whole bunch of these. So for instance, with sine of 0, obviously we just press sine 0 and press enter. And so we know that sine of 0 degrees is 0, but cos of 0 degrees is going to be a little bit different. It's going to be 1. And then we could look at tan of 0 degrees as well. And that's going to be 0 as well. And then just go through and fill out this table just like that. So for instance, I might go to sine of 30 degrees and put that in, and that's going to be 0.5. Now, some of them will be quite long decimals, so I'll move along and I'll do maybe sine of 60 degrees. And just to show you that they're not all going to be nice round numbers. That's quite a mess. So let's just go to 3 decimal places, say, so 0.866. Now, what I want to show you with that is that if I did sine of 150 degrees, so sine of 150 degrees, that's 0.5, which is the same as 30 degrees. That's interesting. What if we did sine of 120 degrees? Oh, well, that looks a lot like sine of 60 degrees, so 0.866. And you might start to notice some patterns emerge. So if you could all complete that table just using your calculator, I'll pause so you can do that on Edpuzzle, and then I will come back and we will go through what we've found as a result of filling out that table. Okay, so now you've had the opportunity to fill out the table, we can start to look at the patterns that form within it. And that's next question A says, what do we notice about the sign of the trigonometric ratios? So obviously, looking at cos and tan first, we'll go back to sine in a minute. And I'll just have to pause there. Sorry about that, return of a whole heap of people to my house. So, as I said before, looking at cos and tan, you notice that once we get past 90 degrees, the numbers start going negative. In particular with tan, you can't actually have tan of 90 degrees, which I'll leave that for you as an exercise. You can have a think about that. Why does a tan ratio of 90 degrees not make any sense? Think about it in terms of how you would draw a right angle triangle where you're thinking about what happens in those situations. So it's not really for this course. We don't have to know why it produces an error, but if you're keen to come up with a reason, then do so and tell me. I'd be interested to see. But what we also notice, in particular with sine ratio, is that sine ratio, it just sort of mirrors around that 90 degrees, and there is no difference there. There's no negative numbers between 90 and 180 degrees. They're not changing at all, which could create some problems. So if we say that cos and tan go negative after 90 degrees, but sine stays positive. So that then leaves us with the question of, well, if we want to find the value of we want to find the size of an angle, and we know that the angle is obtuse, well then how do we do that? And for this, the process is different if we're using either sine or cos and tan. So cos and tan, there's not going to be any difference there. We're not going to. It's going to work just the same, because the values for cos and tan between 90 and 180 degrees are different from the values between 0 and 90 degrees. Although the sign changes, the fact that it's negative is going to tell the calculator that it's an obtuse angle. So I'm actually going to skip that B number 1. I'll go to B number 2. So if I put cos, if I try to find that, obviously to find out what theta is, we've done this before. We use that cos to the -1 button, and it's of 0.21, negative 0.21. Now if I put that into my calculator, we're going to get, so we go shift cos, and we're going to put negative 0.21 into the calculator, and that's going to give us an angle. It's going to give us 102 degrees to the nearest degree, we'll say. So for cos and tan, it just works because the calculator knows if we're getting a negative angle, then it must be an angle bigger than 90 degrees. Now this would be, similar to an angle if we'd taken that negative sign away. If I went back in here and deleted that negative sign, we'd end up with 77 degrees. And you can see here that 77 plus 102, once you allow for the decimal places, they're going to add up to 180. So they're sort of complementing each other, but they're not the same thing. The calculator knows that once you put a negative value in for either cos or tan, that we've got an obtuse angle. But the calculator has no way of knowing with sine that that's the case. So let's have a look up here at sine and look for a pattern. And you'll see here that the 150 degrees and 30 degrees are the same. And we'll also see that 60 degrees and 120 degrees are the same, and this pattern stays the same. If the two angles add up to 180, then they're going to have the same ratio. So if we think about that and play with that a little bit, we'll end up with a situation of if we take 100, if we know it's an obtuse angle, with sine, then what we're actually going to have is our angle we're after is going to be 180 minus the acute angle that has the same ratio. So just to look at that, so if we get 0.5, we're going to have 180, that it's either going to be 30 degrees if it's acute or 180 minus 30 degrees if it's obtuse. If we get a ratio of 0.866, if we're talking about acute angle, we're going to get 60 degrees. If we're talking about an obtuse angle, we're going to go 180 minus 60, which is going to give us 120 degrees. So in relation to that example given here, so first things first, well, let's just find out what theta is. Let's just discuss that, what the acute version of theta would be. So we use that sign of the -1 and put 0.3. We put that into the calculator. And that's going to give us, so we use shift sign because we're finding an angle. I'll just move my calculator out of the way there. So, and we were at 0.3, and we find an angle that's going to give us 17.46 degrees. To 2 decimal places. But we want obtuse. So what we actually need to, the angle we want is theta equals 180 minus 17.46. So we take the angle that it would be if it was acute and take it away from 180. And we can do that on the calculator just by going 180 minus the answer key, and that'll give us, so we are 162.54 degrees. Now, it's okay if this is a little bit foggy today, because it's over the next couple of lessons where this will become a little bit more important. But the important thing here is to remember is that with cos and tan, if we've got an obtuse angle, it's fine, don't worry about it. The calculator will work it out perfectly. But we've got to remember with sine, if the angle that we're interested in is obtuse, then we have to, then the calculator is only going to give us the acute angle. And to find the obtuse angle with the exact same ratio, we need to take whatever that acute angle is away from 180, and that'll tell us what our angle actually is. And that's it for today's lesson.